In this video, we're going to use row operations to solve a system of linear equations in two variables. They give us two equations, 2m plus 10n equals 10, and 12m plus 6n equals 6. I want to get this to an augmented matrix form. So I want to get this so it says A11, B12, A21, B22, with some constants here where we have C of 1, 3, and then C of 2, 3. So this is the A variable column, B variable, and the constant column. So I want to write these two equations like this. These are the coefficients, by the way, of the different variables. And so when I go to write this augmented matrix, I'm going to say that I have 2 for the 2 on the M, 10 for the, and I wrote these as A and B. I screwed that up. This is M and N column. So this should be the M column, and this is the N column. So then this would be 10 here. And then I have 12, 6, and 6. So 12, 6, and 6. And that's how you write this as an augmented matrix. This is the equal sign here. And so what we want to do is we want to get the identity matrix. So 1, 0, 0, 1 is the identity matrix. And we want to get that on the left side. This should just be a line. And we have this here. And then we want the constants still left over here, whatever they are. So this is the identity matrix. Now to get to that point, I'm going to have to do some multiplications and additions to the different rows. And I'm basically using elimination that I would do with normal systems of equations. So the first thing I'm going to do is I'm going to divide the top by 2, and I'm going to divide the bottom by 6, just to make it a little easier. So let's take row 1 and divide by 2, and we're going to take row 2, and we're dividing by 6. That makes the equations easier to work with. So we have 1, 5, 5, and then we'll have 2, 1, 1. So now my goal is to get this to be 0. So I'm going to multiply the top equation by -2. So -2 R1. And when I do that, I get -2, -10, and -10. This is 2, 1, 1. Now I know I kind of just reversed that step that I did in the first piece, but I always like to try to simplify them as much as I can to start the problem. We're going to do row 2 is equal to row 1 plus row 2. So I'm going to add the top row to the bottom row, and that's going to get this to be 0. So I get 0, -9, -9 for the bottom row. On top, I still have this -2, -10, -10 piece. So I'm in a good spot here. I'm going to divide this by -9 here. So I'm going to say -9. We're going to go let's go row 2 divided by -9 and row 1 divided by -2. So you can see we kind of go back and forth between what our rows were before. So this is going to be 1, 5, 5, and this will be 0, 1, 1. And now I'm going to take -5 and I'm going to multiply it times row 2. To do that, I'm going to get 1, 5, 5. -5 times these pieces here, I get -5 and -5. And I'm trying to get 0 in this top right corner because I want the identity matrix. So I'm going to take, and I'm going to add, we're going to say row, I wrote it right here, row 1 is going to equal row 2 plus row 1. And when I add those, add this up, I'm going to get 1, 0, 0. And I still have 0, -5, -5. Now I'm going to take and divide the bottom equation by -5. So I'm going to say row 2 divided by -5. And that will give us 1, 0, 0, 0, 1, 1. So my m variable, remember I screwed that up at the beginning. This is the m column, this is the n column. My m variable is equal to 0, and my n variable is equal to 1. So that means I have 0, 1 for a solution here. And that's how you use Gauss-Jordan to solve this system of equations.